Hello and welcome to our World Meteorological Day podcast. I'm Hannah Cloke, Professor of Hydrology here at the University of Reading, and it's a real pleasure to be hosting today's conversation in our centenary year. The University of Reading has a long history at the heart of global climate conversations, and today it's home to one of the world's largest clusters of climate scientists. Last month, we hosted the International Panel on Climate Change, the IPCC, when more than 100 experts and policymakers from around the world came together to help shape the next international climate assessment. For decades, Reading scientists have played a central role in the work of the IPCC, and our expertise has helped shape many major assessments by the UN's top climate body and has even contributed to a Nobel Prize win. Today I'm joined by two guests who represent Reading's deep involvement in climate science and government policy. Professor Keith Shine, Fellow of the Royal Society, Regis Professor of Meteorology and Climate Science, contributed to the early UN ozone layer assessments and was involved in the very first IPCC report in 1990. And Dr Jolene Cook OBE, a Reading graduate who is now the UK's IPCC focal point and Head of International Climate Science at the Department for Energy Security and Net Zero. In our conversation today, we're going to discover a bit more about their journeys at the university and why they think Reading has become such a force in climate research. Thank you both for joining me today on this Discover Reading podcast. I'm really looking forward to speaking to you and finding out more about your personal journeys. And I'm interested to learn why you think Reading has become so central to global climate discussions and what that means for the next generation of climate leaders. But firstly, hello.
Hello.
Oh, hello. Hello, Keith.
Thank you for joining me in the wonderful Minghella studios here on campus. It's a glorious sunny day outside, not quite so sunny inside. So, Keith, let's start with you as someone at the heart of Reading's world-leading meteorological community. What first led you into meteorology and what was the focus of your early research?
Well, it's one of the things I don't actually know. I remember in my mid-teens, my dad asked me what I wanted to be when I grew up, and I said meteorologist, and I don't really know why I said it. And I think it was, I must have been doing meteorology and geography that day. And so I kept my options open. I went to talk to someone at our local, I grew up in Birmingham, at our local university, who said don't do geography, do lots of maths and physics. Maths wasn't for me, so I did more physics. And I did a physics degree and then a PhD. I started working in meteorology. And from the word go, I was really focusing on what human activity could be doing to the climate system. So that was what my PhD is, and all these years on, I'm still focusing on that same issue. Of course, the priorities change, but that's me, really.
And Jolene, your climate journey began here. So what drew you to study atmospheric sciences at Reading in the first place?
Oh, yeah, so it is. It feels like a long time ago as well. But actually, it wasn't intentional, not in the slightest. I was actually, after leaving university, I actually went into fund management. And kind of off on a whim, I applied for a job as a BBC weather forecaster. Didn't get it because they said I needed meteorology experience. So for some reason, I then left fund management to go and do a master's up in Edinburgh for actually maths to continue my studies there. And then I just saw a job at Reading. I thought, okay, this is my chance to get meteorology experience. So then I came here and took on a research position with Ellie Highwoods. Mm-hmm. And then just kind of fell into it, and then just moved into the climate space. And then after my research position finished, I remember Ellie and Keith both saying, "Why don't you stay on and do a PhD?" Mm-hmm. So I'm like, I'm not sure. Anyway, I did.
We were sure.
I did, and that was the start of it. Really, I just kind of stumbled into climate change. I'm really glad I did. I mean, yeah, it kind of matches how I feel about the environment and things, but it certainly wasn't a planned pathway. But definitely become a career since.
But you didn't make it to weather forecasting?
No, I decided that probably wasn't for me in the end.
Well, it's clear that we've got a lot of maths in the room today as well as a lot of meteorology. Keith, you were involved in some of the first global discussions about ozone layer and climate change. Tell us about that.
Yeah, well, they're very different stories, actually, because in the mid-1980s, we were expecting the ozone layer to get depleted by chemicals we're adding into the atmosphere, but expected it to be rather slow and gradual. And in 1985, the Antarctic ozone hole was discovered, and it was like a big bang for atmospheric science. It was happening at a speed and extent that nobody thought possible. And so it was it was worrying time, but it was also exciting time. It happened to me at a point in my career when I really could dedicate lots of time to it, and the global community really came together, and in a couple of years had firmly understood that the Antarctic ozone hole was being driven by gases that we were emitting, using in our fridges and in our aerosol cans. And it was also, although we've not totally solved the ozone layer issue, ozone depletion issue, it was politically a fairly easy one to solve. It was rather few gases we were putting into the atmosphere that could be replaced by other substances, and industry and policymakers were all on the same side. So that was, some people say it was the best thing the United Nations has ever done, is to get a treaty together to ban these so-called chlorofluorocarbons going into the atmosphere. So that was the ozone hole, but climate change is rather different, because I talked about us expecting the ozone layer to be gradually depleted. Climate change is also, until recent years, a rather slowly evolving problem. And when we wrote the first IPCC report back in 1990, the theory said that climate was going to change because of the gases we were emitting, but we hadn't actually got strong evidence from the observations back then. It was only by the time 10, 15 years later that the really clear evidence emerged. So we were casting around in the dark a little bit. And the other thing which is very different to today is that back in 1990 I could read practically every paper that was published, every research paper that was published in this area, because the global community was so small, and now it's enormous. And I couldn't Are you saying that you don't read all of it? I'm very disappointed. I couldn't read a week's output in a year nowadays, but so it is a very different environment, and there are rather few groups doing global climate modelling using computers, so it was a much smaller community, and so things have changed a lot since then. Today you're the first holder of the Regis Professorship in Meteorology and Climate Science. That sounds very grand indeed. What does that mean? Well, it's an award to the university, not to me personally. So as part of the Queen's Diamond Jubilee back in 2013, universities were invited to apply for a Regis Professorship. And I was part of the team that put the application together, so we were delighted when it was successful. And when it was advertised, I subsequently applied for it and got made the first Regis Professor, so that's great. I mean, it's an interesting thing. There are no royal duties or benefits that go with it, and it's very much, as I said, an award to the university rather than to me personally, but it was still a great honour to be the very first. Yeah. And it allows you a lot of freedom to do what you like. I wish. It still had all the same academic duties. Well, I enjoy teaching. I don't enjoy marking so much, but still have committee work and administration duties. But and what's your favourite class that you teach? I taught climate change and also radiative transfer. That's how the sun's light passes through the atmosphere. So I've always enjoyed doing that. Lots of equations. Lots of equations. I mean, some of the courses are scientific areas that aren't changing much from year to year, so you can almost use the same lecture notes year on year. But climate change is changing every year, so you have to update almost everything every time you give the lecture course. So there are different challenges, but no, I always enjoyed it. Yeah, wonderful. Jolene, so Keith was one of your supervisors when you were studying for your PhD. So what was it like studying here then? Oh, I mean, it was incredible, wasn't it? I mean, it's one of those things you don't appreciate necessarily until afterwards. When I knew I was working in an amazing department, I think, as I said, when I applied for the first research position here, I didn't really appreciate why I was coming to Reading, or the important role that the university and especially the meteorology department played sort of globally, really. So it's funny, I was reflecting on this a few days ago. It was more after I left Reading, in a way, that I really appreciated the role of all the scientists like Keith, Brian Hoskins, and they play worldwide. When you have this outside perspective, and I get involved in the IPCC, and you can reflect on different communities around the world. So
Certainly when I was in the department, things like everyone sitting in the coffee room, you see how passionate everyone is about their research, really important. You see all the incredible stuff that was going on, and being sort of immersed on it day to day was amazing. It was kind of the first time for many, I guess, when I became aware of the IPCC. I think there were 3 things in particular that really stuck out to me. One of them was going to one of the lunchtime seminars that I think Keith and Brian Hoskins and a couple others were talking about their involvement in this government process, a government science process called the IPCC, and they were explaining their roles in it and what they did. They also explained this process at the end of the report when you present this report to all the member governments, and that spend a week in a room with all these governments going through the report sentence by sentence, improving it sentence by sentence. And I very clearly remember and thinking, oh my goodness, who on earth would do a job like that? Hello, sign me up. No, it really stuck out, really important, and seeing these incredible scientists contributing to this report, having such an impact. So that was the first thing. And then the second thing I remember was desperately racing to finish my PhD before the AR4 came out.
That's the 4th assessment report.
The 4th assessment report, yes,
yeah.
Exactly.
Yeah.
Because, the IPCC for many researchers, is, especially early researchers, is like almost like the go-to thing, almost like your Bible. If you want to know about something, you go to the report to learn about it first. And I was so keenly aware that as soon as the AR4 came out, I would have to start referencing lots and lots of other things. I've just written my literature review. I didn't have to want to start looking at other things. I didn't make it, but it was really, it was quite a rush at the end. And then the third thing is the thrill you get from seeing your papers referenced and mentioned in the IPCC reports. I had a couple. I had one on aerosol semi-direct effects with Ellie Highwood that we'd written, and later on the papers with Keith on ways of comparing different greenhouse gases and their impact as well. So I think that's when I started realising, that this is something. And then when I left, took up a role in the civil service. Working for the IPCC on the other side, if you like, for governments, and really seeing what impact the science community, what impact Reading was having worldwide. That's definitely when I got a better sense of the thing I'd been involved in, really. Yeah, really, really important.
Yeah, great. And now you are the UK's IPCC focal point, which is a bit of a weird title. Can you tell us a bit about what that means and what you do?
Yeah, absolutely.
Check sentences, obviously.
Check sentences, yeah. So the IPCC, let's just clarify what that is in the first place. It's formed of member governments around the world, so about 195-ish governments, and who work together to agree on what reports are going to be put together on climate change, or what the scope of those reports is. They consider which experts are going to be involved, etc., and they work with the experts. And each one of those countries has to have a representative on that panel, a focal point, who is responsible for representing their own member countries' positions and priorities, and that's what I do. So I represent the UK in the panel, in the Intergovernmental Panel on climate change. So what do? I have to kind of coordinate the UK thoughts on reports and what priorities they have for research needs and information they want. I have to go to the panel and with my counterparts around worldwide talk about, okay, how do we bring this process together so it delivers reports that meets all the different priorities from different countries. Everyone has different areas they'd like to focus on. Obviously, also when the reports are in draft, I coordinate with my team. I have to say I have a brilliant team supporting me. We share the report across government, so every department, everyone who has an interest in climate action and information the IPCC reports gets a chance to review those reports, and then we submit those reports to the IPCC for the authors, the experts, to consider. And we also help guide the process itself, making sure that the IPCC is very efficient in the way it does its work. But the other thing I do as focal point is obviously we all have huge roles in actually communicating those findings. Once the reports are approved, we've been through that sentence by sentence process, we've got the final report that every government signs up, making sure we share those findings with our government, for example, governments around the world, that the results are very clearly communicated to all the users and stakeholders around. And that's the critical part, really, in the end. It's like making sure that uptake of those reports is as maximised, really. And for my part of role as head of international climate science, it's also making sure that the IPCC and its findings are informing the UN political discussions, so the UN Framework Convention on Climate Change. So that's where all the action is agreed worldwide. So making sure that those discussions are fully based on the science as provided by the IPCC.
I think it's so important that someone in a civil service position has such a strong grounding in climate science, and I know from my many contacts around the world how respected Jolene is, and I'm often told she's a voice of common sense in meetings, because she sees it from both sides, from both the political side and the firm climate science side.
Yeah, it sounds like a very complicated job with lots of different parts to it as well. So,
yeah, it's incredibly interesting. So, I mean, as Keith says, our role is like the bridge between the science and the policy makers, if you like. So you get a real well-rounded perspective of all the different challenges. It's evidence, for example, is not just purely the climate science. Evidence is a lot more things. It's public perception. It's like the wider economic situation. It's lots of different things, and understanding how policymakers bring all that stuff together helps you then give guidance to experts on how best to think about their work and the kind of questions that are being asked that they can really help answer.
The climate crisis is now widely acknowledged as one of the most pressing challenges of our time. So one of the big questions is, how can universities and government play an active role in preparing the next generation of climate science leaders? So I'm going to start with you, Keith, on this one. How do you think universities should do this?
By training the next generation, almost full stop. But I think it goes a bit further than that. I think one of the things, for example, I stress to my new incoming PhD students is that by the time they're in their third and fourth year of their PhD student, they'll be one of the global authorities in their area of science. So it comes in bewildering. There's this big topic, but they're focused on one area, and they'll quickly find themselves, almost a go-to person in these areas. So just encouraging people to realise that they can play a role in climate science. They might feel that, well, I'm a new little PhD student, but actually it's not long before they're contributing. Well, Jolene talked about the papers she was writing as part of her PhD, is that you quickly find that you find a niche and you get respected by a much wider community. So I think it's encouraging students to realise that 2 or 3 years of study in a focused area, that they can become someone really quite established and known in that community.
You must have supervised quite a few PhD students.
Yeah. I've been blessed with some brilliant ones. Although Jolene wasn't one of my PhD students, but she worked very closely with me on a couple of other projects, and it's a delight to have someone like Jolene. I mean, she was mentioning some of the research that we did in the early 2000s, which we didn't really realise at the time was ahead of its time, and most of the modelling groups are only just actually catching up now. So it was a concept of the way we characterise, for example, CO2's effect on climate. And I remember well that Jolene came to our weekly meeting, and she unveiled the results by pulling post-it notes off a piece of paper to show that we'd come up with a better method of doing that. And 5-10 years later, the IPCC adopted it under a slightly different name as the accepted concept of characterising the effect of CO2 and other gases we emit into the atmosphere on climate. So it was just an example how early career researchers and PhD students can make an impact. But it's giving them belief, really, and also giving them room to present their own ideas.
And what are your tricks for giving them belief?
Gosh, I wish I knew.
Just being fabulous.
just being encouraging, I think. Just encouraging them to have the bravery to think about their project and how to present it, and as I say, just to realise that they can make a contribution, however small they might feel as a PhD student. You can, or a young early career researcher, that you can have that impact.
And do you think things have changed since Jolene was at Reading?
Well, I think they've changed massively in many ways. As I said before, just the sheer number of people working in climate science has gone up. So I think it's a little bit harder for the present generation because of that. And just, the observational systems and the computer models are producing amounts of data that were kind of unthinkable when Jolene started out. And again, that's a huge challenge, knowing how to cope with those large amounts of data and whittling it down into making robust conclusions. So I think that's become one of the big challenges. I mean, it's of course an opportunity. We've got all this data, but actually distilling it and digesting it is one of the big challenges we have now.
And Jolene, what do you think the opportunities are for people who want to work with government, so scientists or those who want a career? How would they get started?
Yeah, absolutely. There's a few different ways. I mean, if I firstly think about, if I could just acknowledge some things that Keith was saying about his role in encouraging me, hugely important. And I think professors like Keith have as you say, a huge, a really vital role in making sure bringing the younger generation up and giving them support, showing that there are all these opportunities to feed into processes, helping them understand, helping them build connections and networks, and helping them place their area of research, if you like, in the bigger picture, which I think is quite a lot of it when you start dealing with climate change and climate action. I mean, within our work, as I said, in our team, we were a lot about being the bridge builder, if you like, between the research community and policymakers within government. And we try and meet as many in the research community as we possibly can. Within my work, I make sure that we put a lot of emphasis on speaking to the research community in the IPCC, providing lots of support to the UK's IPCC community. The role of, I would say, early career scientists is hugely important. It's something within the IPCC is very strongly supported. We're doing quite a lot of work there on bringing some of these new researchers who have different perspectives, come from different generations, have different ways of working in, sometimes from some of the more well-established professors within the process. And that's hugely important. Lots and lots of support for that. And for example, I think when the IPCC workshops were here a few weeks ago, I was involved in an event for early career researchers, which is hugely important. These are people who don't necessarily know the ins and outs of how the IPCC works necessarily. So to have the focal point and the secretary from the IPCC speaking about what it involves, how they can get involved as both as authors, contributing as authors to the process, or looking at the research they produce and the papers they produce and how you can use those, and or even working as, say, chapter scientists supporting authors. These are really important roles. And the other thing is about actually getting involved in the expert reviews of the reports as well. I mean, it's a great chance to see the draft reports, understanding how things are being framed and put together and synthesised. And it's the IPCC assessment is very different. It's really not just a literature review. It's quite a different process, and I think unless you're involved in it and seeing it and experiencing, I imagine for many of these early career scientists, it's quite difficult to understand. So as I said, within our role, there's my team, and which we sit in within a bigger team of climate science advisors. We reach out, we speak to lots of the research community around the country, and for me, worldwide as well. We help, provide a bit of guidance to researchers on what are the latest policy priorities in terms of the questions they're asking. So, definitely if you're in an early career stage researcher, try and get in touch with us or colleagues and talk to us, make connections. We're all lovely people. We like having these chats. Helps us, build our knowledge too. And and the other thing is look at those opportunities that the IPCC presents. So, my team will advertise when one of these IPCC opportunities comes out. Try and take them if you can. And even if you're not successful, you can. It's a way of registering your interest. It's a way of getting yourself known to this community. And by doing that, by getting involved with IPCC, you're exposed so much more to how this research is used to actually push climate action, which is hugely important.
Okay, so to finish off, a tough one, okay? Reading University is currently celebrating its 100th anniversary. So where do you see the biggest challenges and opportunities for climate action over the next century? Should we start with you, Jolene?
Yeah, sure. Well, many challenges, aren't there? So there's still a fundamental point about helping people understand why climate action is needed among all the other priorities and challenges that people are facing today. How do you make the case that you should be thinking about moving to renewables, thinking about where you're getting your energy from, thinking about how you do your day-to-day life, when you're worrying about how you're going to feed your kids, for example, how you're going to get them to school, how you're going to look after your health, how you're going to find a job. Really, really, really challenging. So there's something about helping people understand that these actions that you're that are necessary to tackle climate change offer you benefits as well for your life. They offer you the chance to have a healthier life in the future. Greener space, better air quality. They can offer you different and newer and better jobs. But that's a real challenge, and the communication around this is really difficult. Those who are kind of pushing back against net zero are quite willing to come up with your fake facts, quite willing to attack the fundamentals of climate science. So there's something about helping, I would say, the general public and think about the way we communicate things in a way that really resonates with people in their everyday life. And there's also the point about bringing all the different sciences together as well. It's no longer just about physical climate science, so the climate models, etc., and just saying this is happening, it's getting warmer, etc. It's more about how do you bring those together with people who are designing cities, etc., or designing infrastructure. How do you bring in the other expertise? How do you bring engineering together with the physical climate science? How do you bring it together with social scientists? So there's a real need to be much more interdisciplinary in the way we approach problems to understand pathways to climate action. So huge things. And then I guess if you put it in world context as well, every country has its own priorities. A lot of things, especially around adaptation, are very context specific. So there's something about trying to understand all these, getting to know the audience, getting to know their particular circumstances, to provide the kind of relevant information. And I would say that's where the IPCC obviously comes into this. Is it has all these voices feeding in, has all these different policy exposure to different policy priorities from government representatives. So hugely important. But that's not to say that when you're looking at adaptation, for example, you still need those local voices feeding in, and I think there's a lot more work being done now, especially in the IPCC, to bring those voices on board.
Thank you. So Keith, what about you? What opportunities give you the most hope?
I think the most hope is that we're understanding what parts of our understanding is robust. So we know if we emit carbon dioxide and other greenhouse gases into the atmosphere, it causes climate change, and the evidence is unequivocal. But beyond that, there's still a lot of puzzles to keep us going from a science point of view. And one example, a gas I've worked with a lot over the years, is methane, which is being emitted by both industry and agriculture. There's lots of puzzles how it's changed over the past 20 years, and that's something that young researchers, that's just one example of a puzzle that young researchers can get involved with, is trying to untangle it. And it is that this interdisciplinary thing. It's the kind of area that involves agriculture, it involves industry, it involves atmospheric chemistry, atmospheric physics, so it covers a broad range of subjects, and I think it's an exciting area that we can go. And of course the other thing is that we've got more sophisticated models, we've got more observations, and so we can begin to fit pieces of the jigsaw puzzle together in a way that we weren't able to 10, 20 years ago. So I think the jigsaw puzzle's getting bigger, the number of pieces in the jigsaw puzzle's getting bigger, but it's exciting to be part of putting all that together, and that's why I hope it will continue to inspire young scientists to get involved in this area and contribute to it.
Thank you so much, both of you, for talking to me today. It's been really interesting. I'm sorry we didn't get to talk about your weather forecasting for any further. And I'm still very disappointed that you didn't choose geography back in those years, as a geographer myself. Half geographer, half meteorologist. Yeah, it's been really interesting talking to you both, and I've learned a lot about the IPCC process, and I will let you back out into the sunshine.
Thank you, Hannah. It's enjoyable.